Hello fellow travellers. I thought it was about time that I showed you some of the progress that's been made on this DC ball valve controller. It's almost completed. I'm waiting on some minor parts. I'm waiting on mini USB connector for the valve wiring, which will go in here to replace this tangle of wires, and I'm waiting on a digital flow meter which will go in here and will actually send the real-time flow figures through this to the eParrot/distillator, so that the actual flow can be digitally controlled from the panels. So in the box we have an H-bridge controller. We have a Nano, great little unit these, I think. We have a DC to DC controller. I have a 15 volt supply here, which is chopped down to just under 13 at the output, and through the H-bridge to the motor controller, where it ends up at about 12.1 or 12.2 because of the voltage drop through the H-bridge. Over here we've got an I2C connector, which will allow two-way communications back to the eParrot/distillator. This is a mega test board acting as a dummy transmitter for the unit. So you can dial up an opening from the eParrot/distillator, and it will control the slave unit, send it to the slave unit. The slave unit will control the opening, and the actual openings are then sent back to the master unit. So it's a two-way communication. Closing this up, we have the front of the box with the label, the button label that is mentioned in the handy hints and tips section, which I put on today. So on power up, this unit will do automatically initialize, but it's already done that, so I'll do it again. So we just press initialize, and it will do 3 runs, limit switch to limit switch. It calculates the time, the cycle time, and averages it, and then uses that to determine the step time needed for the 1 degree closing and opening increments. That last little jerk was moving from full close to just close, which is about 12 degrees off full close. So having initialized it, we can now do manual control, fully open, fully close. We can step open 1 degree at a time, and step close, etc. So the same commands can be sent via the I2C connector in the master, and again we have the we'll have actual logic control over the opening depending on feedback from the head temperature. The deflag temperature reading will be sent back to the eParrot distillator, and then that will be sent to this unit to ascertain the required opening to control the output of the still. So there you have it. I hope it helps. Oh, I was going to show you this. This is a sample of the tough labelling that you get from using the liquid polystyrene that I mentioned in the handy hints and tips, and the adhesion of it to the plastic. It's just been coated with, well, read the hints and tips section and you'll see. And by brushing the same stuff onto the back of it and putting it onto the styrene, you can see that it's stuck forever. And also the strength of the mix for making joints instead of commercial styrene cement. It's great stuff. Very, very tough. Very tough. Very tough. Can't be torn. Waterproof, can be stretched slightly, but good stuff. Okay, there we go. See you later.